Welcome. Today, we're embarking on a real deep dive, a masterclass on a topic that truly defines our modern world, yet so often goes unexamined. We're talking about artificial intelligence. But we're not just going to talk about what it can do, we're going to talk about what it eats. We are peeling back all the layers to look at the AI's content diet. Think about that for a moment. These powerful, almost alien digital minds that are reshaping our society, they're being fed, they're being shaped, they're being trained and defined by the vast, messy, beautiful, and sometimes terrible ocean of human media. What we're investigating today is the fuel, not just any fuel, but the very fuel that powers the engine of the 21st century. This is the story of how our words, our images, our culture is being used to build the new giants of the digital age.
So let's start with a question that sounds deceptively simple. If you go to an AI, a large language model, and you ask it to write a poem about, say, a sunset, where do the words it uses actually come from? I mean, really, where? Do they just appear out of the ether? Is there some new emergent consciousness in the machine that's suddenly feeling poetic? The answer, as you might guess, is no. But the real answer is so much more fascinating, and frankly, so much more complicated. This isn't just a technical question for engineers. It's a profound question about the nature of knowledge, of creativity, and ultimately, of power. Answering it properly is a journey, and that journey is going to take us from the very bedrock of the internet, the hidden rules that govern how data moves, all the way to the highest stakes courtroom battles that are happening as we speak, pitting creators against the biggest tech companies in the world.
To really unravel this mystery, we need a roadmap, and here it is. First, we're going to start at the bottom, with the digital ocean's rules. We need to understand the fundamental architecture of the internet itself, because its strange, fragile nature has huge implications for everything built on top of it. Then, we'll look at the engine of intelligence. We'll pop the hood on these AIs and see how they actually learn. After that, we get to the absolute heart of the matter, the fuel. This is where we'll explore the monumental copyright crisis that's erupting because of the data these engines consume. That leads directly to the next question, the intermediary's burden. If an AI does something wrong, who's to blame? From there, we'll turn to the ethics, to the ghosts in the machine, the hidden biases and risks that get baked into these systems from their data diet. And finally, we'll zoom out and ask the big question. How on earth are we supposed to govern these new giants?
Okay, let's begin. Part 1. Before we can even get to the AI itself, we have to understand the world it lives in, the environment it was born into. And that environment is the internet. I want you to really think about the subtitle here, understanding the infrastructure that holds the world's information. We take it for granted, don't we? It's just there, like water or air. But it's not a natural phenomenon. It's a human creation, a piece of infrastructure built on a set of rules. And to understand the new, complex ships sailing on this ocean, these powerful AIs and platforms, we absolutely have to start by understanding the rules of the ocean itself. Because those rules, as we're about to see, affect every single vessel, from the largest battleship to the smallest raft.
This analogy, right here, is absolutely central to our entire discussion today. So let's spend a moment to really unpack it. The internet is an ocean. Now, think about your own personal cybersecurity. The antivirus you run, the passwords you use, the phishing emails you do or don't click on. That's about maintaining your own ship. Maybe you work for a huge corporation with a massive cybersecurity budget. You're on a giant, well-defended aircraft carrier. Or maybe you're just a regular person on your home laptop. You're in a life raft. Your personal security is a risk to you. But that's not what we're talking about today. We're talking about the governance of the ocean itself. We're talking about the currents, the shipping lanes, the storms, the very physics of the water. These are the systemic issues. A rogue wave doesn't care if you're in a battleship or a life raft. It affects everyone. And it's at this deep systemic level, the governance of the entire ocean, that we have to begin our investigation.
So when we talk about governing this digital ocean, it really breaks down into two distinct spheres. On the left, you have what we call narrow governance. Honestly, this is the boring stuff that nobody ever thinks about, but it's the most important part. It's the literal plumbing of the internet. Think about IP addresses. Every device connected to the internet needs a unique number. Who hands those numbers out? How do we make sure nobody gets the same one? That's the job of organizations like APNIC. Or domain names. ICANN is the body that coordinates the system to make sure that when you type in a web address, it goes to the right place. This is the unglamorous technical foundation. Now on the right, you have broad governance. This is the stuff we see in the news every day. This is the society that gets built on top of the plumbing. It's the endless debates about platform liability, privacy rules, what constitutes free speech, how to fight cybercrime, and here is the crucial takeaway. All the heated, complex, broad social issues on the right are fundamentally constrained and shaped by the narrow technical rules on the left. You cannot have a meaningful conversation about fixing society's problems online if you don't first understand the plumbing they are all built upon.
This brings us to a frankly terrifying and fascinating core concept about how that plumbing works. It's a system that can be described as routing by rumor. See, unlike the old telephone system, where a central operator would connect your call through a specific known path, the internet is completely decentralized. It's a web of millions of independent networks. When your computer sends a piece of data, an email, a picture, anything, it doesn't have a full map to its destination. Instead, it gets passed from router to router, and each router along the way only knows its immediate neighbors. It essentially asks, of all my direct connections, who is the next best hop to get this data packet closer to its final address? It gets an answer from a neighboring router, and then it just trusts it. It forwards the packet based on that recommendation, that rumor. It's a global system built entirely on a chain of local trust, with no central map and no overarching verification.
So, what happens when that system of trust breaks? This timeline gives us 3 absolutely perfect and alarming case studies. Let's really dig into these. First, 2008. The government of Pakistan decided it wanted to block access to YouTube within its own country. They ordered the state-run Pakistan Telecom to do it. An engineer went to implement this block, but they made a critical error. Instead of just telling routers inside Pakistan to send YouTube traffic into a void, they accidentally broadcast a message to the entire global internet saying, "Hey everyone, I'm Pakistan Telecom, and I am now the fastest, best, most efficient route to get to YouTube servers." And because the internet works by routing by rumor, routers all over the world believed it. They said, "Great, thanks for the tip," and began diverting all of their YouTube-bound traffic to Pakistan, where it just vanished. For several hours, YouTube was effectively offline for the entire planet because of one typo amplified by this fragile trust-based system. Then you have 2010. This one's a bit more mysterious. For 18 minutes, about 15% of the world's internet traffic, including data from the US military and other government sites, was inexplicably rerouted through servers in China before continuing to its destination. Was it an accident? Was it a test to see if they could? We still don't know for sure. But it proved that a major network could intentionally or not redirect a massive slice of the world's information flow. Finally, 2017. This shows it doesn't even need to be a government. A single Google engineer in Japan makes a configuration mistake. The error itself only lasted for 3 minutes, but the bad routing information they broadcast spread like a virus. The result? For the next 8 hours, major services across Japan were knocked out. You couldn't use online banking, you couldn't buy train tickets, online games that so many people rely on were down. A 3-minute error by one person caused 8 hours of nationwide chaos. These 3 incidents perfectly illustrate just how fragile the internet's core design really is.
Now, in the world of information security, there's a foundational model we use to evaluate how secure a system is. It's called the CIA triad. Let's break it down. Confidentiality is about secrecy. Is the information protected from prying eyes? Think of it like a sealed envelope. Integrity is about accuracy. Has the information been tampered with or changed? Is the message inside the envelope exactly what the sender wrote? And finally, availability. This one sounds simple, but it's crucial. It means authorized users can actually get to the information when they need to. The information is there for you. Now, let's look at that 2008 YouTube incident through this lens. Was it a failure of confidentiality? Not really. No user data was stolen. Was it a failure of integrity? No, YouTube's videos weren't altered. But was it a failure of availability? Yes. A colossal, global, catastrophic failure of availability. For legitimate users all around the world, the service simply wasn't there. This proves that the fundamental design of the internet, this routing by rumor system, has a massive inherent vulnerability in one of the 3 absolute pillars of information security.
Okay, so we've established the nature of the ocean. It's vast, it's interconnected, and it's shockingly fragile.
Now let's turn our attention to the new kinds of ships that are starting to sail on it. Large language models, or LLMs. This is where we move up from the deep infrastructure of the internet to the engine itself. We're going to peel back the curtain and ask a fundamental question. How does this technology, this artificial intelligence, actually work? How does it think?
And so we come back to that central question we started with. But now we have all this crucial context about the internet structure. How does an AI actually learn? What is the process? Well, the simple answer is that it learns by consumption. It learns by ingestion. It's fed an amount of data that is almost impossible for a human mind to comprehend. We're not talking about it reading a few books or a few websites. We're talking about it consuming a significant percentage of all the text and all the images that humanity has ever digitized and put on the public internet.
This is the single most important concept to grasp to demystify the magic of AI. At its very core, a large language model isn't thinking in the way a human does. It's not conscious. It doesn't understand concepts. What it is an incredibly vast and mathematically sophisticated pattern-matching machine. After being trained on, say, the entirety of Wikipedia, billions of web pages, and a library's worth of books, it doesn't learn what a dog is. It learns the statistical relationships between the word dog and millions of other words. It learns that bark, loyal, pause, and leash appear near dog very frequently. So when you give it a prompt like the fluffy dog chase the, it's not thinking about a dog. It's performing an incredibly complex calculation to predict the next most likely word in that sequence. And it'll probably predict ball or cat or car, because in its training data, those are the patterns it observed over and over again. It's a prediction engine, one word at a time.
This quote, which was inspired by a fantastic lecture on this very topic, captures the nature of an LLM perfectly. Because it operates on statistical probability, not on genuine understanding or connection to reality, it is an expert at producing text that sounds correct. It's fluent, it's grammatically perfect, it's convincing. But it has no concept of truth. It's a convincing bullshitter. There was a perfect example of this in that same lecture. The lecturer asked an image-generating AI to draw a picture of the three main Taiwanese presidential candidates standing in front of the presidential office building, a very specific prompt. The AI produced a picture of four generic-looking men in suits standing in front of a generic-looking government building. It didn't know who the candidates were. It didn't know what the building looked like, but it recognized the pattern. Politicians, in front of, official building, and it generated a statistically plausible but completely factually wrong image that fit the pattern. That's the convincing bullshitter in action.
Okay, so we have this fragile ocean, the internet, and we have this powerful new engine, the LLM, this incredible pattern-matching machine. But every single engine, no matter how powerful, needs fuel. And this, right here, is where we pivot to the absolute core of our explainer today. The fuel for these AI models is, well, it's us. It's our culture. It's the entire corpus of human-created media. And the act of taking all that content and feeding it into the machine has ignited a monumental legal, ethical, and economic conflict. This is the copyright crisis.
Let's take a closer look at this AI's diet. The scale and variety are just staggering. First, you have web text. Companies use datasets like the Common Crawl, which is basically a snapshot of a huge chunk of the public internet, scraped at a massive scale. Then you have books. We're talking about vast digital libraries, like the controversial Google Books project, which digitized millions of volumes. Then code. All the publicly available code on repositories like GitHub is prime training material for teaching AIs how to program. For images, you have datasets like Leon 5B, which contains over 5 billion image and text description pairs scraped from the web. And finally, there's user data. Every time you have a conversation with a chatbot, every time you give it a thumbs up or thumbs down, that can become more fuel, more training data to refine the model. Now here's the critical point to understand. This fuel is our collective digital culture, and the overwhelming majority of it was created by artists, writers, photographers, and programmers who never in a million years imagined it would be used as raw material to train a commercial AI that might one day compete with them.
This situation creates a truly fascinating and mind-bending legal paradox. Let's break down both sides of it. On the left, we have the AI's output, the poems, the images, the code it generates. Under current U.S. law, this content is generally not protected by copyright. Why? Because copyright law is built around the idea of a human author.
An AI is not a legal person, so it cannot be an author. Therefore, what it creates falls into the public domain. Okay, simple enough. But now look at the right side, the input. The training data is filled to the brim with copyrighted material, books, articles, photos, artwork. The AI companies argue that using this material for the purpose of training is a fair use under copyright law. But the creators of that material call it mass-scale, unlicensed copyright infringement. So think about the paradox. The output isn't copyrightable because a human didn't make it, but the input might be illegal precisely because humans did make it. It's a legal and philosophical knot.
And I want to be very clear. This is not a theoretical academic debate. This is an active, raging legal crisis playing out in courtrooms right now. You have the New York Times, one of the world's most respected media organizations, suing OpenAI and its partner Microsoft, alleging that their models were trained on millions of copyrighted articles. You have visual artists who have filed lawsuits against image generators like Stability AI and Midjourney, claiming these models are essentially just tools for high-tech plagiarism of their styles. And you have a whole class action lawsuit joined by famous authors like George R.R. Martin and John Grisham against OpenAI. All of these massive legal battles boil down to one central, multi-billion-dollar question. Is the act of training an AI on copyrighted data a transformative new use, creating something totally new? Or is it simply the largest, most efficient act of intellectual property theft in human history?
So this copyright crisis over the training data naturally leads us to the next thorny question. What happens when an AI, having been trained on all this copyrighted material, then produces an output that is very, very similar to one of its training sources? If it spits out a paragraph nearly verbatim from a New York Times article, or creates an image in the unmistakable style of a specific artist, who is legally responsible? Who gets the blame? This forces us to dive into a legal concept called intermediary liability and figure out where these new AI giants fit into the existing legal frameworks.
To understand liability online, you have to again think about the internet in layers. At the very bottom, you have the physical layer. These are the literal fiber optic cables under the ocean, the satellites in space. The companies that own these are like the road builders. Above that is the logical layer. This is the addressing system we talked about earlier, DNS and IP addresses, that act like the street signs and house numbers. And then at the top, you have the application layer. This is where we all live our digital lives. It's Google, it's Facebook, it's Amazon, and now it's ChatGPT. These AI companies are platforms. They operate at the application layer, just like social media companies. And for decades, we've been arguing about what level of responsibility these platforms have for the content that flows through them.
Now, here's a brilliant real-world analogy from a legal case that helps frame this debate. A hypermarket, a giant supermarket, was sued because it was selling some traditional Spring Festival couplets that it turned out infringed on someone's copyright. So who's at fault? The artist who made them or the store that sold them? The first court that heard the case ruled that the hypermarket was responsible. They said the store has a duty of care over the products it puts on its shelves. But then the case went to an appeals court, and that court reversed the decision. They ruled that the hypermarket was not responsible. Their reasoning was that a store selling thousands and thousands of items can't possibly inspect every single one for potential copyright issues. They argued the store is just a venue, a physical platform. They rely on guarantees from their suppliers, and if they receive a complaint, they follow a notice and takedown procedure. They get a notice, they take the product down.
And that brings us directly to the core dilemma for AI. Is an AI company like OpenAI just a hypermarket for information? Or are they merely providing a venue or a tool that generates text, and they can't be held responsible for every single one of the billions of possible outputs it could create? Can they just rely on a notice and takedown system? Or are they more like a publisher who has a fundamental duty of care over what they produce and should be held responsible for any infringing content their model generates? This is the exact fundamental question of liability that courts and lawmakers are grappling with this very moment. Are they a venue or are they a publisher? The answer will have trillion-dollar consequences.
So far, we've really focused on the technical and the legal dimensions of the AI's diet. But now we have to turn to what might be the most important dimension of all, the ethical one. Because when you train an AI on a massive data set that reflects human society, it doesn't just learn our knowledge. It doesn't just learn about science and history and art. It also learns our flaws.
It learns our prejudices, our stereotypes, our inequities, our historical biases. These are the ghosts in the machine. The risks that are born directly from this training data diet are profound and multifaceted. At the top of the list is bias and discrimination. If the internet text an AI is trained on contains stereotypes about certain groups of people, the AI will learn and perpetuate those stereotypes. It's a garbage in, garbage out problem on a societal scale. Then there's privacy invasion. What if someone's personal information, their name, their address, their medical history, was scraped from some corner of the web and included in the training data? The AI could potentially reveal that private information in its responses. Then there's misinformation. We've already talked about the AI as a convincing bullshitter. Its ability to generate fluent, plausible-sounding text makes it an incredibly powerful tool for creating and spreading false or harmful content at scale. And of course, there's the economic risk of job displacement. All these risks are born directly from the data the AI is fed.
This case study provides a perfect, concrete example of how these ghosts get into the machine. Imagine you feed an AI a ton of public health data about COVID vaccine distribution. The data clearly shows that certain neighborhoods have much lower vaccination rates than others. An AI, being a pattern-matching machine, will spot this pattern instantly. It will see the strong correlation. And it might conclude that the reason for this is that the residents of that neighborhood are making a choice not to get vaccinated. That's the simple, direct conclusion from the data. But the AI can't see the context that isn't in the dataset. It can't see the reality on the ground, that maybe that neighborhood has fewer clinics or a lack of public transportation to get to them, or maybe there's a deep historical mistrust of the medical system in that community. The AI learns the correlation, but it completely misunderstands the causation. It mistakes an effect for a cause, and in doing so, it creates a biased and potentially very harmful conclusion that blames the victims of a systemic problem. That is the ghost in the machine at work.
Now, the good news, if there is some, is that the world is waking up to these massive challenges. This isn't a new conversation. As this timeline shows, the awareness of these ghosts has been growing rapidly. Back in 2016, this was mostly a conversation happening in academic circles and research labs. But by 2018, you saw major tech companies feeling the pressure and starting to publish their own internal AI ethics principles. By 2019, it went international, with bodies like the OECD and the G20 establishing high-level principles for trustworthy AI. Then in 2021, we saw a huge leap forward when the European Union proposed its landmark AI Act, a formal, comprehensive legal framework. And by 2023, you have dozens of countries around the world developing their own national AI strategies, almost all of which are focused on how to manage these exact risks. The push for governance is no longer theoretical, it's global, and it's accelerating.
And this brings us to our final and perhaps most difficult section. We have seen how these AIs are built on the fragile infrastructure of the internet. We've dissected the copyright crisis their insatiable hunger for fuel has created. We've examined the thorny liability questions they pose. And we've looked at the ethical ghosts that haunt their training data. So, the challenge that lies before all of us is immense. How do we, as a global society, chart a course for the future? How do we govern these powerful new giants that we have created?
What's absolutely fascinating to watch right now is that there is no single consensus emerging on how to do this. Instead, we're seeing a global divergence in regulatory philosophies. You have the European Union leading with a very comprehensive, top-down, risk-based approach. Their AI Act categorizes different AI uses by risk level, and high-risk applications will be very strictly regulated. Then you have the United States, which is so far favoring a more flexible, sector-specific approach. It's less about pre-market regulation and more about accountability, transparency, and letting different industries develop their own standards. And then you have a different model from a country like Japan, which is promoting a society-centric approach that emphasizes social responsibility, collaboration between government and industry, and ensuring AI is developed according to human-centered principles. For the foreseeable future, there won't be one global rulebook for AI. There will be a patchwork of competing ideas and regulatory frameworks.
As we draw to a close, this all brings us back to what might be the most profound and difficult philosophical question at the very heart of this topic. We've established that the training data for AI is a mirror. It's a mirror held up to humanity. And that mirror reflects everything: our greatest scientific discoveries, our most beautiful works of art, but also our deepest inequities, our ugliest prejudices, our entire history of unfairness. So the question we have to ask ourselves is this: Can we ever truly build a fair AI, an unbiased AI, when the very raw material we are using to construct it is the data from our deeply and often unfair world?
And so, this is the final thought I want to leave you with today. Let's return to our analogy one last time. We as a society built the ocean, the vast, fragile infrastructure of the internet. Then we built the ships, the platforms and companies that sail that ocean. And now we have reached a point where the navigators of those ships are themselves becoming artificial. They're making decisions, charting courses. So the ultimate question for all of us, for every citizen, every policymaker, every creator is this: who gets to write the new maps? Who decides the values, the rules of the road, and the final destinations for these new forms of intelligence that we've unleashed upon the world? That is the immense responsibility and the incredible challenge that lies right in front of us.